this mini tutorial, we're going to go ahead and take a look at how to determine the number of protons, neutrons, and electrons in an atom or isotope. So I am pulling to kind of walk through this, an example from your textbook. So it is on the atomic structure and symbolism section of the Unit 2 part of your textbook. So under the Check Your Learning, there is a little word problem that states platinum has a mass number of 195 and contains 74 electrons. It then wants you to determine how many protons and neutrons are in this isotope of platinum, and then also the charge of the platinum. So you will need your periodic table heavily for this particular unit. Make sure that you either have one printed out that you really like, or there's a good one that is in the appendices. At the very end, you'll find, if you look through all of the units, at the very end is the appendices, and there's a periodic table there. So pretty much for this whole unit, you're going to need that periodic table. I put just a little shortcut. This was in your reading as well, how we find all of those particles in an atom. The atomic number is the number of protons in the nucleus. The mass number is the total number of particles in the nucleus. So that would be our protons and our neutrons. And finally, to find the charge of an ion, we have to take the protons and subtract it from the electrons. So again, back to this example, this is how we are given the question. Sometimes you'll also see it in what we call nuclear symbol notation, which I wrote over here. There is a really nice explanation in your textbook that shows you kind of what numbers go in each area around the atom. So make sure to review that. It'll be really helpful when you're going through and doing your assignment. So in regard to this question, the first question we're asked is the protons. So the protons is the same as the atomic number, and that's always just going to come right from the periodic table. So if you have your periodic table out and you locate platinum, the symbol is PT, you will find that it is element number 78. Therefore, that means that it has 78 protons. The number of protons can never change. If you change the protons, you will always change the atom. So if you wrote down 79, then you would no longer be talking about platinum, you would be talking about gold. So this is a super important number because it identifies the atom. Now neutrons and electrons can change. You can have different numbers of neutrons, you can have different numbers of electrons and still be the same atom. So that one is, those ones you have to get a little bit more some more math involved to figure out what's going on there. So to find our neutrons, if I go up here, I know neutrons can be found if I know the mass number and the protons. I know the mass number and I know the protons. So if protons plus neutrons is what my mass number is, I can just do some really simple moving around of this super basic equation. If I want to solve for neutrons, that just means that I'm going to take the mass number and subtract out the protons. So this is kind of your basic setup. And again, you might be asked to solve for any one of those. Well, actually, either of these protons you always know. Just be able to rearrange that super easy equation. So whenever we do that, we're going to take our mass number, which we're given. You'll always have to be given the mass number. That cannot be found on the periodic table. So our mass number is 195, and we're going to subtract out our protons, which we found, if we look up platinum, is 78. And if you take 195, you subtract 78, that's going to give us our number of neutrons, which is 117. All right, last part is charge. Up here, the charge is found by taking the number of protons minus the electrons. Okay, so I know, since it's platinum, that we have 78 protons, and we're going to subtract protons, and we're going to subtract the number of electrons, which we are given in the problem. So we are told we have 74 electrons. And if I subtract those two, I'm going to be left with a plus 4. So that's going to be my charge, okay? If you would have, for example, let's say that we had something like fluorine that we were doing. And we were told that for fluorine that we had 10 electrons. Okay, if we wanted to find the charge of that one, I would take, again, my number of protons minus electrons. So my protons I get from the atomic number, which is 9. And I would subtract from it the number of electrons, which is 10. So this is an instance of where it would be negative for my answer. So charges must have a plus or minus accompanied with them. For this one, if you just wrote 4, then it would probably be marked incorrect. You need to designate if it's a +4 or if it's a -4. It's not just assumed if you leave that off that it's positive. For charges, you must include the positive or the negative.